matrices. We want to look at what a matrix is and the various types of matrices. Now, what is a matrix? A matrix is an arrangement of numbers or letters in rows or columns. Now, let's look at one way that you might have a matrix being formed. Suppose, for example, you sell apple, orange, and cherry. Now you have a table with these. So you have a table for apple, orange, and cherry. And you have 3 classes of these fruits, all right? You have class A. Now, class A fruits are very well preserved. They are the most expensive, and you can sell them at a high price. Then you have class B. You might have a few bruises here and there, just a little bit overripe, but you can sell them at a fairly high price, but not as high as A. Class C are those that are overripe, they're well bruised, they're not in very good condition, and you can sell them at a low price or even give away some of them. So, apples. You have 15 class A apples. You count that there are 7 class B and 5 class C. Orange, you have 21 that are in class A. You have 15 in class B and 10 class C. Cherry, you have 55 that are the highest class, well preserved, well kept. Then there are 20 that are in class B, and you have 17 in class C. All right? After a while, you get accustomed to this type of table, so you now can just write the numbers down alone. So you have 15, 7, 5, 21, 15, 10, 55, 20. This was supposed to be what? It's supposed to be 17. Oh, 17, right. So you remember that here you have apple, orange, cherry, and these are A, B, and C. Now, a matrix will have these numbers surrounded by round brackets, just like this. All right? Now, these numbers that are lined up horizontally are arranged in rows. So, the rows, you have row 1 at the top, row 2 in the middle, going like this way, row 3, and these are row 3. Then the ones that are lined up vertically are called columns. You have column 1, column 2, and column 3. All right? Now, if you have another matrix like this, so you have 3, 7, 8, 19, then you have 2 rows and 2 columns. If you have yet another matrix like this, 5, 4, 9, 16, 2, 0, 1, 7, 8, then you have How many rows? 3. And going down 3 columns. Now, you call these going horizontally as rows. One way to remember that the horizontals are the rows is to, for example, remember that when you're lining out chairs, there is going to be a meeting, and you're putting the chairs like this. You're putting in rows of chairs. Or if you have students lining up, forming lines to go to different counters in the tuck shop to buy lunch, right? They should form neat, straight rows. So going side to side, horizontally, these are rows. You're forming a row. And then you might have a building, and you have this round cylindrical concrete part of the building that holds up this section of the building. You call it a column, right? You notice that the columns are vertical, up and down. The only time you find columns that are horizontal is when they're not ready to be installed yet and somebody leave them for the construction workers to install. But once columns are installed, they go up and down. You have to look up and down to examine them. They are vertical, so they are columns, just like with the matrix. So you have rows and columns. Now, the order of the matrix. When you have a matrix like this, 2, 1, 5, 7, 8, 3. This matrix has, say, row 1, row 2, only 2 rows. And how many columns you have? Let's just use C for column. Or we could just use R for rows. You know what R and C mean by now. 3 rows, 2 rows and 3 columns. So the order of this matrix is, remember, here it is written as row by columns. Generally, it's row, multiplication sign, columns. So it is a 2 by 3 matrix. The order of this matrix is 2 by 3. It means it has 2 rows and 3 columns. Alright? You see that? 2 rows and 3 columns. So, let's look at the various types of matrices. Remember, it's one matrix, more than one matrices. Alright? So in this case, I had put matrix here, show one matrix, more than one matrices up here. Alright? So matrices is a plural, matrix is a singular. So, here now, the row matrix is really a matrix consisting of one row. Suppose you say 3, 7, 5. That's a row matrix. It has one row. It doesn't matter how many columns you have. If you have 10, 30, that's a row matrix. Alright? So, that is the row matrix. What about the column matrix? Well, you guessed it. It has one column. Suppose you have 5, 10, 13. You have 3 rows. Right? Row 1, row 2, row 3. 3 rows. But only one column. So this is a column matrix. Alright? One column. So that's a column matrix. Suppose now you have what is called the null matrix. What is that? Remember, if you did sets before, you would have done the null set, and it's the set that contains no elements. And by the way, each item in the matrix is called an element. Right? In set, you say each item in it, each number that you write in the set or letter is an element or member of the set. With matrices, you say each of these is an element. You have 5 as an element, 10 as an element, 13 as another element, 7 is an element in this, and so on and so forth. So a null matrix might look like this, all zeros. It might look like this. Alright? So what you have are zeros in that matrix. Now, suppose you have, alright, so have this. Suppose you have this matrix 0, 0, 0, 0. Or it could be, for example, this matrix 1, 3, 2, 6. You notice that you have 2 rows and 2 columns. You might have another matrix. Let me get rid of these. You might have another matrix looking like this. 7, 9, 6, 4, 3, 2, 1, 8, 7. You have 3 rows and 3 columns. This is a 3 by 3 matrix. This is a 2 by 2 matrix, and so on and so forth. These are called square matrices. Alright? Square matrices. Remember that a square has the width and the height being the same. If you consider the number of rows to be the height of the column this way, and the number of columns the width, the number of rows the height of the matrix, and the number of columns the width of the matrix, then you have the same number of rows and columns, same height, same width. So it's a square matrix. Alright? Now, you might say, what about rectangle? Because you remember the term rectangle. All of these are really rectangular matrices. Alright? But this one, the 2 by 2, 3 by 3, and so on, those are square matrices. That's a square. Then you have the diagonal matrix. Let's look at what that is all about. The diagonal matrix. Remember, dia means across, and you're measuring across. Now, if you have a matrix like this, 1, 5, 7, 2, 3, 9, 4, 10, 15. This is the diagonal. However, this is not a diagonal matrix. A diagonal matrix would look like this. You have 1, 0, 0, 0, 7, 0, 0, 0, 4. Now that is a diagonal matrix. Alright? You have a diagonal here with numbers. The diagonal matrix, in this case, is really a matrix that has all the elements except the leading diagonal, 0. Now, in this diagonal, upper left to lower right, that's called the leading diagonal. Alright? That's a leading diagonal. If you have a matrix like this, let me write that again. 0, 0, 2, 0, 4, 0, 5, 0, 0. That's not a diagonal matrix. Here, all the elements are 0 except these in the diagonal, but this is not the leading diagonal. The leading diagonal is this one. Right? So let me erase this. This is not a diagonal matrix. This is a diagonal matrix. The elements in the leading diagonal are not 0, but all other elements are 0. Alright? So that is the diagonal matrix. The unit matrix, what is that? You remember that when you talk about unit, it means you talk about 1. Now the unit matrix is a diagonal matrix with the leading diagonal elements equal to 1. So let's see what that is about. You have 1, 0, 0, 0, 1, 0, 0, 0, 1. That's a diagonal matrix. These are 3 by 3. It could be a 2 by 2 as well. 1, 0, 0, 1. That is a unit matrix. This is a unit matrix. Alright? If you change this to 2, it's no longer a unit matrix. It's a diagonal matrix, but not a unit matrix. But if you change it back to 1, it is not only a diagonal matrix, but a unit matrix as well. Alright? So, in that case, you have the unit matrix. Now, when you have the unit matrix, right? Or say any matrix. Suppose you want to write this matrix again, and again, and again. It would be inconvenient to keep saying 1, 0, 0, 0, 7, 0, 0, 0, 4. And then suppose you had to write it 5 times. Right? What you need to do is give it a name instead of writing open bracket, all the numbers and close brackets. Just give it a name. Now the name that I just want to make sure that I take this within the unit matrix. Alright, the name that you want, you should give the matrix. Don't give it a number. And don't give it a name like John or Mary. Give it a single letter. And it must be uppercase. So if this is what I want to call A, I say A equal. And then wherever I write the matrix A, you know that this is the matrix I'm talking about. Alright? Now, when it comes to the letter I, the practice is to reserve the letter I for unit matrix only. Unit matrices only. So I. Alright? So you call that I. Now if you have 2 different unit matrices, you might want to call this I1 and I2. Right? Or since you consider 3 rows, 3 columns, you might call this I3 and this I2. Whatever the case is. But when it comes to unit matrices, use the letter I to name them. Right? Now the thing is, if you don't want to use I1 and I2, right, you might even call this another letter, A. But the thing is, if it's not a unit matrix, don't use the letter I for it. Just reserve I for the unit matrix. Alright? Now, we'll continue later on with more matrices on how to deal with matrices in mathematics.